Here we go. Bless you. I was not a student teacher here. I was I was right out of college. We'll leave it at that. All right, these are inequalities, which means we see shading, okay? What you need to do is figure out what the parent function is. What is this a true shape of? If you're going to try and, can you close the door for me? Thanks. If you're going to try and graph these. Now I'm looking for sketches, so points of inflection need to be appropriate, and then the basic sketch after that is okay. This is what kind of a parent function? So this looks like y equals x squared, and this is the shape of a what? It's a parabola. You need to know these things, all right? Going to calculus next year, you're going to be talking about finding limits on curves and being able to graph this stuff, and this stuff you need to know now, all right? This is a parabola that opens which way? It opens up because it's positive, and that means the vertex is where? 4, -3. So remember, change the sign, keep the sign, right? So this is a translation, 4 units to the right and 3 units down, okay? So 4 units to the right and 3 units down means we have a parabola that opens up. Now, we know how to graph linear inequalities that have equal signs, right? So the rule kind of is if it's strictly less than, or strictly less than or greater than, what kind of a line do we draw? Dotted. If it's greater than or equal to, or less than or equal to, then we use a solid. So what kind of a line am I going to use when I draw this curve? Solid. So I just want you to kind of do this. Now, I want to know where that vertex is. All right. Is it always going to cross over into the other? Yeah, eventually it will, yeah. Okay. Okay, then the question is going to be, in this case, because it's a parabola, our options like in absolute values will be either inside or outside our curve. So remember the rule has always been, and we did this with the linear programming, put your pencil on the y-intercept and travel according to what your inequality says. Our inequality says that y is less than then tells me am I inside that shape or outside? And so here is the graph for that. The parent function for this one is just the absolute value of x. It's a parabola, yeah. So the parent function for the next one is an absolute value. We know what an absolute value looks like. We know that if we were to write it in standard form, what we might really want to say is the absolute value of x plus 1 plus 2. We might want to move that 2 to the other side so that we get it in standard form. And that means that in our parent function, where the vertex would be at the origin, we have now moved it how many units? Left 1 and up 2. With a slope of what in this case? So we can graph this one a little more accurately. Solid or dotted? And putting your pencil on your y-intercept and traveling up or down the y-axis according to our inequality tells me I'm shading where? Inside. Because I'm traveling up, that leaves me in. Meg? It depends on what they're giving you. There were a couple where they gave you, like, I think there was a greatest integer function plus 1, and then they did something to it. And so they were asking, what is the change with respect to what they gave you as the parent? Okay. All right. What does a cubic root look like? Okay, it's doing this. It's hugging the x-axis. Okay. And so it has a point of inflection. Normally it's right here at the origin. But according to our movements that we learned in the second section, that point is moving where? To the right one and up two. And so it's going to come down low and go up high because it's not negative in front. We haven't reflected it. And it's solid, isn't it? So we're going to put little arrows on the ends. And we're going to put our little pencil on our y-intercept, and we're going to go according to the inequality, and my option is now above it or below it. And so where would I be graphing this? Because it says less than, I am below. This is why you need to know what the shape of that parent function looks like so that we can do this kind of stuff. Okay?
We have a question. So when the parent is y is the cubic root of x, that's when it hugs the x, but if it was like x cubed, that's when it hugs the y.
Yep. Helene, do you have a question? All right, this one's a little weird. This one has what inside? Which means it's the shape of a parabola, right? But it's also inside an absolute value, isn't it? Think about how to do that one.
There was one where it stopped at the y and then just repeated on the opposite side.
Yeah, but this is different. Let me think. I wanted to say that this would be something like I think this is going to be over 4, no, and down 3. I think it's something like this. But anything that's negative is going to get positive, so this portion is really up above. So this is the graph of that. Oh, thank you. We'll make it dotted. What just happened? Wait. And I think probably what I wanted to do was really this. Let's rewrite this like this. Let me see what I wanted to do on this one. Hold on. I might just skip this one altogether. Yeah, I still want the absolute value because what the absolute value does is it makes that part positive. But hold on a second.
So that means instead of having a -4, it would actually be a positive.
It's going to flip it up. It's going to flip everything that's negative. Hold on.
No, but when you're finding like where it is, like on the x-axis, it really becomes negative, but then it's -4 inside of absolute value. So it's really to the right 4 and down.
It's like a mind
Am I right?
getting low.
Oh, it has the square root. Like your hair.
It's a mind thing.
You do the square root after the absolute value? What? You square it. There's a square on the outside. Sure. But like, oh, I don't know. You don't actually go and square it. So it's like the vertex you think was at -4. But then does it? But why does it not? But then it's in an absolute value. Exactly. Yeah. It's a positive change. No, but when they're in an absolute value, they don't change. Yeah.
All right.
No, but absolute value 0 is positive numbers. It's how far away you are from 0. No, because
The answer is the answer, not all the individual signs don't change. It's just the.
This one was a -1. Like the second problem we did, and the inside was 1, but then vertex was -1.
But like without the absolute value.
All right, we're going to just skip that one because I'm not sure what I wanted in this one. We'll just skip it. All right. All right. Here we go. Let's go on to this next one. Mine was a mess. Was yours a mess? It's like. All right. Mine was a mess. It was like all lumped together, so I separated it. What do you have for the first one? I couldn't even read what I had. You don't even have this one? Boy, I don't even know where that came from. Well, let's go ahead and do it anyway. Supposedly you guys don't have the first one? This is just solving, and this will be a review. Anytime you're trying to solve something in absolute value with an inequality, you want to think of the fact that you have two cases. So what you're going to want to do is solve for the absolute value. So in this case, what would I do to solve for what's inside the absolute value? Subtract the 3. So that gives me with absolute value of x minus 4 greater than 5. And then we create our two cases. Case 1 without the absolute value symbol says that x minus 4 is truly greater than 5. What does case 2 say? Less than negative 5, right. So you got to change the direction of the inequality. You remember doing this? Yeah. And changing the sign of the answer. Those are the two changes that occur when you're doing your second case. So this tells me that x is greater than 9 and x is less than. So if we were to graph this, greater than 9, less than negative 1. Is this an and statement or an or statement when the graphs are going away from each other? Because it looks like oars in the water. Like if you're rowing a boat, you're doing oars in the water. You're going in opposite directions. Oh, I know. I imagine this is on your homework if it's on the notes. I don't know if they will have you graph them, but they will definitely want you to solve them. Okay. All right. So again, we will know that we've got two cases. We're going to solve for the absolute value. So the absolute value of x minus 2 is really less than 10. And my two cases then are x minus 2 less than 10 and x minus 2 greater than negative 10. So x is less than 8 and x is greater than, no, x is less than 12, sorry, and x is greater than. So looking at this, here's negative 8 and here is 12. Open, open. Where is the shading or the graphing? In the middle. So is this an and or an or statement? It's an and statement. So and statements are written together with the x in the middle. We know it's less than 12, greater than negative 8. Or statements can be written separately, and statements written as one inequality statement or one line.
When you're writing the or statements, you have to go in like the negative times direction.
Yep. Number from smallest to largest. All right. So then this last one. What's weird about this last one? I got two x's, but it follows the same idea. You write your two cases. You're going to say 3x minus 4 is less than or equal to what? And then what's your second case going to say? Yep. And we go through the motion of solving for x. This tells me that 2x minus 4 is less than or equal to 0. So 2x is less than or equal to 4. So x is less than or equal to 2. This one says 4x minus 4 is greater than or equal to 0. So 4x is greater than or equal to 4. So x is greater than or equal to 1. And so, is this an and statement or an or statement? Because we're greater than 1 and less than 2, so we're going to put them together as an and statement.
Wait, where did you get the 2 from?
Take the 4 over, divide by 2.
No, when you went from 3x.
Subtract, subtract. I'm just moving my x across the inequality by subtracting it. Think of it as just a regular algebra problem. Does that make sense? Was that a yes or a no? Okay. Is that it? Okay. So easy. C. Okay. All right, so let's take a look at the homework.